Stretching a staggering 60,000 miles, your blood vessels could wrap around the earth twice. But what do these intricate pathways actually do? And why are they vital for life? Let's dive into the fascinating science of blood vessels. Blood vessels are the dynamic pipelines of the circulatory system, responsible for transporting blood throughout the body. They deliver oxygen, nutrients, hormones, and other vital substances while removing waste products like carbon dioxide. Picture this. Some blood vessels are as wide as a garden hose, while others are thinner than a human hair. These vital highways power every beat, breath, and step you take. Major blood vessels are the superhighways of this network, enabling efficient blood flow across the body. Blood vessels are classified into three main types. First up, arteries. They carry oxygen-rich blood away from the heart to the body. Arteries are built for high-pressure delivery, channeling oxygenated blood swiftly to tissues. Arteries are thick-walled, elastic vessels designed to withstand the high-pressure flow of blood from the heart to organs. They consist of three layers: the tunica intima, a smooth inner lining ensuring efficient blood flow; the tunica media, a flexible middle layer of smooth muscle; and the tunica externa, a protective outer layer. The largest and most prominent artery is the aorta, which originates from the heart's left ventricle. It consists of the ascending aorta, supplying the coronary arteries, the aortic arch, which branches into carotid and subclavian arteries, and the descending aorta, delivering blood to the abdomen and lower body. Its elastic walls effectively manage pressure surges caused by each heartbeat. The carotid arteries are vital for supplying blood to the brain, neck, and face. Blockages in these arteries can lead to strokes, emphasizing their importance in maintaining brain health. Pulmonary arteries are unique among arteries as they transport deoxygenated blood to the lungs for oxygenation, playing a crucial role in respiratory function. Renal arteries deliver blood to the kidneys, ensuring filtration, toxin removal, and regulation of blood pressure. Lastly, the femoral arteries supply blood to the legs and lower body and are frequently utilized in heart procedures like angiography, highlighting their clinical significance. Now, the veins. They return oxygen-depleted blood back to the heart. Veins serve as the low-pressure return pathways, bringing oxygen-depleted blood back to the heart. Veins have thinner walls and a wider diameter to accommodate the lower-pressure blood flow back to the heart. Equipped with valves to prevent backflow, veins are especially important in the legs, where gravity opposes blood return. Despite working against gravity, especially in the lower body, veins effectively manage this task with the help of valves and muscle contractions. The superior and inferior vena cava are the largest veins in the body, responsible for collecting blood from the upper and lower regions, respectively, and directing it to the heart. Pulmonary veins, unique among veins, carry oxygen-rich blood from the lungs to the heart, highlighting their pivotal role in oxygenation. Jugular veins, running parallel to the carotid arteries, drain deoxygenated blood from the brain, face, and neck. The portal vein carries nutrient-rich blood from the digestive organs to the liver for metabolic processing, underscoring its significance in nutrient management. Lastly, femoral veins return blood from the lower limbs to the heart, ensuring efficient circulation even in the farthest parts of the body. Lastly, the capillaries. They are tiny vessels where the exchange of oxygen, nutrients, and waste occurs between blood and tissues. Capillaries serve as the exchange hubs of the circulatory system, connecting arteries and veins while facilitating the transfer of gases, nutrients, and waste between blood and tissues. Their single-cell thick walls are specifically designed to allow easy diffusion, making the exchange process highly efficient. Their narrow structure ensures red blood cells pass through one at a time, maximizing their contact with surrounding tissues. Forming dense networks within tissues, capillaries maximize their reach and ensure that every cell receives the necessary oxygen and nutrients while effectively removing waste products. How do blood vessels work? 1. Blood flow regulation. Blood vessels respond to body demands by constricting, which means narrowing, or dilating, which means widening, to control blood flow. Vasoconstriction narrows vessels to increase blood pressure and reduce blood flow. Vasodilation widens vessels to decrease blood pressure and improve blood flow. 2. Role of endothelium. The endothelium, the inner lining of blood vessels, releases substances like nitric oxide to regulate blood pressure, clotting, and immune responses. 3. Pressure system. Arteries work under high pressure to pump blood efficiently, while veins rely on valves and surrounding muscles to return blood to the heart. Let's talk about some common blood vessel disorders. First up, we have atherosclerosis. This condition involves plaque buildup in the arteries, which leads to narrowed or even blocked vessels. This significantly increases the risk of heart attacks and strokes. The main causes: high cholesterol, smoking, high blood pressure, and a poor diet. Next, we have varicose veins. These are enlarged, twisted veins that occur due to valve dysfunction, causing blood to pool. They're most commonly found in the legs. Then there's aneurysm. This is when a weakened arterial wall bulges out, and if it ruptures, it can cause life-threatening bleeding. Hypertension or high blood pressure is another major concern. Excess pressure damages vessel walls over time, which can lead to heart and kidney issues. Finally, we have deep vein thrombosis, or DVT. This is when blood clots form in deep veins, often in the legs. If these clots dislodge, they can lead to a pulmonary embolism, which is quite serious. How blood vessels heal and adapt. Blood vessels are, remarkably dynamic and capable of repair and adaptation. One key process is angiogenesis. This is the formation of new blood vessels from existing ones, especially during wound healing or after an injury. Another fascinating adaptation is collateral circulation. In response to blocked arteries, the body can create new pathways to bypass the obstruction. And then there's regeneration. Endothelial cells can repair minor damage, but chronic stress, like smoking or high blood sugar, can overwhelm this ability. How can you keep your blood vessels healthy? A healthy diet is crucial for maintaining blood vessel health. Omega-3 fatty acids found in fish help reduce inflammation and prevent plaque buildup. Antioxidants like vitamin C and vitamin E protect vessel walls from oxidative damage. Regular exercise is another key factor. It improves circulation, strengthens vessel walls, and promotes the release of nitric oxide, which enhances vasodilation. Staying hydrated is also important as it prevents blood from thickening and promotes smooth blood flow. Lifestyle choices play a significant role too. Avoiding smoking and limiting alcohol intake can prevent damage to the endothelium. Managing stress is essential to avoid prolonged vasoconstriction. Finally, some amazing facts about blood vessels. Did you know that if laid end to end, an adult's blood vessels could circle the earth twice? Capillaries are so small that red blood cells must travel through them in single file. The total blood volume in an adult body completes a full circulation in just 1 minute. And, interestingly, blood vessels have their own blood supply through tiny vessels called vasa vasorum, especially in large arteries and veins. The aorta is as wide as a garden hose. Veins hold 70% of the body's blood at any moment. Blood flow in the aorta can reach speeds of up to 40 centimeters per second. In essence, blood vessels are the unsung heroes of the circulatory system, tirelessly working to sustain life by delivering nutrients, removing waste, and adapting to your body's needs. Understanding their function and maintaining their health is essential for overall well-being. From the massive aorta to the microscopic capillaries, these highways ensure every cell gets what it needs to thrive. Protect them through a healthy lifestyle, and they'll keep fueling your body's journey for years to come. With advancements in medical science, the future of vascular health looks even brighter. See you next time. Keep watching MedGrow and take care of yourself.